This is the solutions to the v equals d over t homework. You can fast forward to check some answers, slow it down and watch an explanation, whatever you need. What is the distance covered in 4 hours if the average speed is 35 meters per second? Well, that's straightforward. That's just one equation. The only thing I have to watch here is my units. This is meters per second, so that means my distance has to be in meters, my time has to be in seconds. So, when this is hours, I know I have to change that. So I'll do my factor label to change hours into seconds. Four times 60 equals 14,400 seconds. So now I just plug everything in. The velocity is 35. I'm looking for the distance, and the time is 14,400. To get d by itself, I just multiply both sides by 14,400. And you get 504,000 meters. I should probably watch sig figs there. I only started with 2 sig figs here and 2 sig figs here. So my answer should only have 2 sig figs. So I should say maybe 500,000 with a bar over the 0. Too late now. The video's made. How long does it take to run a marathon, which is 26 miles, if your average pace is 6.1 miles per hour? Well, my units are okay. I'm in miles per hour, and my distance here is in miles. So I know my time is going to turn out to be in hours. I'm talking about an average speed, so I can use my equation, v equals d over t. And then my velocity is 6.1. And then my distance is 26. And I'm looking for the time. Remember, this is the simple math that people screw up. It might help to think of it as 2 steps. Multiply both sides by t. And now to get the t by itself, divide both sides by 6.1. So t equals 26 over 6.1. I divide that and I get 4.3 hours. Okay, I was good at sig figs this time. I started with 2 sig figs. I rounded my answer to 2 sig figs. If you cover 320 miles of a 500-mile trip in 5 hours and 20 minutes, how much time did it take for the rest of the trip? I forgot a P there. If you average 57.2 miles per hour for the whole trip. This is one of those trip problems. You can tell I've got a couple different distances, a couple, it's not just a simple v equals d over t. More complicated. So I'll set up my structure. I know this is the 3 different parts. I can think of the first part of the trip, the rest of the trip, or the second part of the trip, or I can think of the trip as a whole, the whole trip. For each part of that, I can use my constant speed or average speed equation. Okay, 320 miles of a 500-mile trip. So 320 is what I already did. That's the distance for the first part. And 500, that's the whole trip. That's the distance for the whole trip. So that first part we did in 5 hours and 20 minutes. Got to put that all in hours because my velocity is in miles per hour. So 20 minutes, I know that's 1/3 of an hour, or 0.33 if I put it as a decimal. So altogether, my time for the first part of the trip was 5.33 hours. How much time did it take for the rest of the trip? So that's what I'm looking for, is that t. If you average 57.2 for the whole trip, so whole trip. So the point is not to fill in like everything. I don't need everything. I just need my answer. All I need is to find this time. Yeah, I could look at this right now and say what the rest of the distance was, but I don't need it. That doesn't help. All you need is this time. If I can get the total time, subtract the time I already did, then I'll have this time. So I'm solving for the total time. Remember, don't screw up this math. Think of it as multiplying both sides by t, and then dividing both sides by 57.2 to get t by itself. So I get a total time of 8.74 hours, and I know that we already used 5.33 hours of that in the first part, so that leaves 3.41 hours for the rest of the trip. Number 4, you average 45 meters per second for 2,500 meters, then 52 meters per second for 1,700 meters. So I can tell already this is one of those trip problems. What was the average speed for the entire distance? Let's set up the structure. So let's fit my numbers into the structure. 45 meters per second for 2,500 meters. So that's a velocity and a distance for the first part of the trip. Then 52 and 1,700, so that's the second part. 52 is the velocity, 1,700 is the distance. What was the average speed for the entire distance? So if I find that v, I'm done. The only way to get a velocity is if I can use this equation. Velocity equals distance over time. I can already tell the total distance. If this was the distance for the first part, that's the distance for the second part. I'll add them up together, and that will be the distance of the whole trip together. So I got that from adding the first part of the trip and the second part of the trip. So the total trip was 4,200 meters. I'll do the same thing with the times. They'll add up, but I'm going to have to find them first. I'm going to cross multiply, or think of it as multiplying both sides by t. So 45t equals 2,500. To get the t by itself, I'm going to divide both sides by 45. So my time for the first part of the trip is 55.6 seconds. I'm going to multiply both sides by t, divide both sides by 52, and I get that t equals 32.7 seconds for the second part of the trip. So now I can add these two times together and get the time for the whole trip together. So now I know the distance for the whole trip and the time for the whole trip. I just have to divide to get the velocity, the average velocity for the whole trip. So once again, I'm getting a little fickle here with the sig figs. Everything up here started with 2 sig figs. They're placeholders. 2 sig figs, 2 sig figs. So my answer, probably I should have written 48 meters per second. You want to average 65 miles per hour for a 350-mile trip. If you average 52 for the first 75 miles, what speed must you average the rest of the trip? Another trip problem. Set up the structure. 65 for a 350-mile trip. That's the whole trip. So that miles per hour, that's the velocity of the whole trip. 350 miles, that's the distance for the whole trip. If you average 52 for the first 75 miles, so this is the first part of the trip. So 52, that's the velocity. 75 miles, that's the distance. And I'm looking for the speed for the rest of the trip. Remember, the only way to find v is if I know this d and this t. I could find the distance right now. I know the whole trip was 350 miles, and I already did 75 miles in the first part of the trip. So subtract to see how much distance is left for the second part of the trip. So now I'll do the same thing with times, but I have to find the times first. So I'm going to solve for time for the whole trip and solve for time for the first part. I'm doing the same math here, so I'm going to kind of do them both at the same time. Solving for t here, solving for t here. Multiplying both sides of the equation by t cancels. Multiplying both sides of the equation by t over here, t cancels. So over here I have 52t equals 75. Over here, I have 65t equals 350. I'm going to get t by itself now. So over here, I have to divide both sides by 52. Over here, I have to divide both sides by 65. So I can divide and get the first part of the trip. Has a time of 1.44 hours. I know it's hours because it's miles per hour. And get the whole trip. Takes 5.38 hours. And now I can subtract. 5.38 for the whole trip. Take away the 1.44 hours that I already used on the first part of the trip. And I get that there's 3.94 hours left for the rest of the trip, or the second part of the trip. And now I just divide. 275 divided by 3.94 is 69.6. That's the velocity, so it was miles per hour. Last problem. Bonnie walks 2.5 meters per second. Tessa walks 3.7. If both start at the same place at the same time, how much later does Bonnie arrive at the destination that is 2 kilometers away? So we've got a velocity for Bonnie, velocity for Tessa, and a distance. But notice they don't all agree. These are meters per second, and that's kilometers. So I'm going to have to put my kilometers in meters, because my distances have to be meters, my times have to be seconds. So 2 kilometers is 2,000 meters. So this is not a trick problem. It's not like this happened and that happened and add them together. No, I've got two different things going on here. I've got Bonnie walking at her speed. I've got Tessa walking at her speed. So I'll do some structure. Bonnie's average speed, Tessa average speed. This looks like it's going to be one of those Harry Larry kind of problems we've been doing in class, where it turns into a big system of equations. Let's see. I know her velocity. I know her distance. I know her velocity. And I know her distance. So, I mean, I could solve both of these equations for t. I can find Bonnie's time, and I can find Tessa's time. So this is not like those Harry Larry problems. This is, I mean, I'm using a lot of t because it stands for time, but these are not the same time. This is not a system of equation. I can solve this and get Bonnie's time, and I can solve this and get Tessa's time, and then I can easily answer the question. Divide both sides by 2.5 to get t by itself. And I calculate that Bonnie's time is 800 seconds. And now I'll calculate Tessa's time. I'll divide both sides by 3.7. And I get that Tessa's time is 541 seconds. So if it took Bonnie 800 seconds, but it only took Tessa 541 seconds, you can subtract to answer the question and see how much later Bonnie arrives. So now I just need to subtract to see how much later Bonnie arrives. So it took Bonnie an extra 259 seconds. And once again, 2 sig figs, 2 sig figs, 2 sig figs. My answer should probably be 260.